Now that we understand some basic vocabulary related to probability, we're going to want to go ahead and calculate some basic probabilities. And the formula that's going to carry us through the first, portion of our unit here, very common, very basic formula, is the one I wrote down over here. You're going to express probability as a fraction, where the top of the fraction is how many desired outcomes there are. Those are the ones you're looking for. So how many ways are there to get what you want, over how many possibilities are there altogether. If you can remember that formula, you should be in pretty good shape for these probability questions. So there's going to be a couple examples here, and please pardon my pictures. I drew them the best I could, but you'll see is that they are a little sloppy at points. So like if this one, we're going to spin a spinner, and it's going to randomly pick a number off of this. We are assuming that all portions, like all the little pie slices, are the same size, even though some of them look a little bit tinier. But assume that they're all the same size and all are equally likely to occur. Number one asks us to list this sample space. Remember, the sample space is just a list of all the possibilities. So it's going to be the numbers 1, 2, 3, all the way to 8. I use that ellipse right there, the dot, 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 just because their numbers are going to keep the same pattern there. And they stop at 8. Now, the second problem, you'll see this P and then this parenthesis right here. And on the inside of the parenthesis, we describe the outcome that we are looking for in our problem. So we're looking to spin this spinner and get a 3. Well, according to our formula, the top number is supposed to be the number of desired outcomes. Well, we want to get a 3, and there is one way to get a 3. Over the number of total outcomes. Altogether, there are 8 possibilities in our sample space. So the probability of spinning a 3 is 1 over 8, if you want to write it as a fraction, or you can write 0.125 if you prefer writing it as a decimal. So you can think about that as like a 12.5% chance that if you spin the spinner, you're going to get a 3, which in the grand scheme of things is not that high of a number because there's a lot of other numbers out there. On number 3 here, we want to spin the spinner and get a number greater than 5. So if we look at the spinner here, well, we can get a 6, we can get a 7, or we can get an 8. So there are 3 good things that we would want out of still 8 altogether. So 3 out of 8, if you write that, you can leave it as a fraction, or it would be 0.375 as a decimal. Probability of spinning a number greater than 5 is 37.5%. So we're going to go through just a couple more examples here. And again, I apologize if the pictures are a tiny bit messy. I tried my best. What we're going to do now is we're going to look at this bar graph right here. And it's just a sampling, I guess, of a bunch of people and their jobs. We have some lawyers, nurses, doctors, and veterinarians. And I went ahead and wrote down how many of each there are. So there's 16 lawyers, 21 nurses, 9 doctors, and 28 vets. And the first problem asks us to find the probability that if I pick somebody at random, they're going to be a doctor. Well, I have 9 doctors I need to figure out how many people there are altogether. So then we'd have to do 16 plus 21 plus 9 plus 28. Just add all of it up to see how many people I'm dealing with. And when I do that, it appears that there are 74 people. So 9 over 74 is going to be my answer for this one. And because you have to either reduce your fraction, which it turns out this doesn't reduce anyway, so you're okay in that sense. But it's when the numbers are bigger like that, decimals are often good as well. There's about 0.12 if you round to be 122. So a little over a 12% chance that if you pick somebody, they're going to be a doctor. For the second one here, you want to pick somebody and have them either be a nurse or a lawyer. Well, we still have 74 people that we're picking from, and we'll be happy if we get a nurse or a lawyer. Those are the first 2 bars right here. So altogether, there are 16 of these guys, 21 of them. There's going to be 37 out of 74 people. So if we add those up together, that's how many we end up with here. Now this one does actually reduce, so if you're going to leave this as a fraction, you should reduce it to 1 over 2. Or you could always just go with a decimal. It's going to be 0.5. So there's a 50% chance if you pick somebody, they're either going to be a nurse or a lawyer. Last problem in this video is probably the most challenging because it not only involves probability, but it takes a little bit of geometry into account as well. So what's going to happen here is we have this dartboard. It's right here, and you're randomly going to throw a dart somewhere and it's going to hit in this area. Each of these little pieces here from the middle to there is 3 inches or whatever you want to say long. This part from here to here is 3, as is this one. So the first problem asks us, and then there are 10 points for the middle part, 5 points for this inner ring, and then 2 points for the outer ring. We want to know the probability that if we throw that dart at random, we're going to get 10 points. Now, these outcomes are not equally likely. This area right here, like the size of this part, is not going to be the same as this part, not the same as this part. So it's not as easy as just doing 1 over 3 possibilities. For this one, to find out the total for the whole dartboard, the total amount of space, we're actually going to find the area. The area of this dartboard, it's a circle, and again, I apologize, the picture's supposed to be perfectly circular here. The area of the whole thing, so I'll put it with like a little W below it for whole, is going to be pi times r squared. So in this problem, the whole thing, there's 3, 3, and 3, the radius is 9. So I'm going to do pi times 9 squared, and I'm actually going to go ahead and leave this in terms of pi. The area of the entire picture is 81 pi. So what that means for me, let me zoom out just a little bit here. What that means is that the bottom of my fraction, the total, is going to be 81 pi. And the top is going to be the area that has 10 points, which is this little inner circle in the middle here. Well, that inner circle, you're going to do area equals pi times, the radius is 3 squared. I'm going to get 9 pi for the top. And I can go ahead and reduce these fractions here. 9 pi over 81 pi. The pi's are actually going to cancel. I can reduce 9 over 81 and I get 1 over 9, which as a decimal is 0.111 repeating. So there's about an 11% chance if you throw that dart, it's going to land in the middle. All right, last problem here. We want to find the probability that we get 2 points, which is going to be from this outer ring around the edge. We still want to put it over the total area. All the possibilities. There's a total area of 81 pi. Now the trouble is that finding out the outer ring is not, like there's no shape, we don't have an area formula for like the donut on the outside right here. Because what we're looking for is the area of just this part that I outlined in blue here. So what I'm actually going to do, and this is a little bit trickier, but I'm going to find the area of the rest of the shape, so these inner 2 rings together, and I'm going to take that away from the total. So the inner 2 rings, it's got a radius of 6 right here. Again, I'm looking at just the purple circle. So I'm going to do pi times 6 squared, you get 36 pi. Now if the inside purple guy is 36 pi, I want to take that out to get what's left over. So what I'm going to do here is 81 pi minus 36 pi, which is actually equal to 45 pi. So the area of the blue part, long story short, is 45 pi. And you can actually reduce this one as well. It will reduce to 5 over 9. Or if you don't want to do that, just type it in the calculator and get your answer. It's going to be 0.555 repeating. So there's about a 55% chance that you will land in that outer ring.